And today my paper that is a deep learning based zero watermarking for the authentication of medical record, and I'm very proud to present in this conference. So giving a brief intro about myself, my name is Gurleen Kaur and I'm fourth year computer engineering student in Thapar Institute of Engineering and Technology. And my co-authors are Bakul Gupta and my professor Ashima Anand. She was also guidance toward this paper. So the very first step, that what motivated us behind this work. The first thing is that we all live in technologically so advanced world. So in today's digital age, the use of digital media have been a very much tremendous in numbers. Like for an example, from starting from the medical images to the e-commerce to even the social media, we all use images in a lot kind of ranges. So digital images, they contain a lot of sensitive and the confidential information, which can, if tampered with, can lead to the significant consequences such as identity theft, loss of personal information, and even the financial losses. So, despite the availability of highly secure algorithms, security remains a significant concern. We know that in today's age, the technology is so advanced, right? So there are a lot of new latest technologies which are even securing these types of images, but still there is a need of rapid emergence of new technologies that can breach it at the same end also. So their security is of a great concern in today's time. So what the solution that we have proposed to this problem? The very first thing that we have used is that the confidential data, it should remain inaccessible to the intruders. See, for an example, if someone in any case, as the technology is so advanced, is able to like change the data or take the image, so what it should be done, that that image should remain inaccessible to the intruders. So what we have used fragile type of data hiding technique. If I use the term fragile, that means if that image has been given to the wrong hands, that hand should not be able to view the image. So that is why I have used here fragile type of data hiding technique, where the slightest tampering to the image by an attacker, the information that is a watermark image is completely destroyed, hence preventing it from any unauthorized access. So this is how we have used here, and also a hybrid transformation including DTCWT and NSST is used to fuse to medical images to form a more sophisticated output image. So what is happening here is that we are taking two images here. We are securing the medical images. So on the first step, what we are using is we are taking two medical images. We are doing a fusion on it, and after performing fusion on it, we are converting it into one single image. And then on that single image, we'll be doing various processes like the hashing and everything, which will be coming in the upcoming slides, that how we are going to secure it. Further, the zero watermarking model is implemented using the ResNet 50DL model for more precise result and extraction of feature maps. Now, why we have used the digital watermarking? There are a lot of novel applications for the digital watermarking available. Like it can be used for the copyright protection, it can be used by the military, it can be used by the digital forensics, by smart healthcare, secure e-voting, chip and hardware protection, fingerprinting. Digital watermarking is very emerging nowadays. See, digital watermarking is not only visible, or it can be invisible also. And here in this case we have used is in the case of the invisible watermarking, that another person, he or she, will not be able to see that whether the watermark is present or not in the image, but that watermark is embedded in the invisible way, can help us to secure it in some way. Now there are a lot of difference between robust and fragile watermarking. If I talk about robust watermarking, so it is considered that it can be used for the images which are widely distributed and which are widely shared. On the other hand, the fragile watermark, it is used for the digital signature, for the critical verification. And see, let's first understand what is a major difference between fragile and robust. In the robust, what happen if there are some kind of attack, like for example, there is a cropping attack or there is JPG attack, where there is some change in the image has been made. In that case, even after that attack has been performed, the receiver would somehow be able to retrieve that image properly, to guess it that what the image was sent by the sender. But whereas in the fragile watermarking, if even there is a slight change in the image, there is a slight attack performed on the image, even the 1%, then the receiver would never be able to retrieve the real image. So that means fragile is going to be very highly secured, whereas robust in that case is quite less secure. That wise robust is majorly used on the images where the receiver ends are very large in number, that is widely distributed. Now, if I talk about the detection process, so in case of the fragile watermarking, it is easily detected. For example, if there is any watermarking present in the fragile one, I'll be able to easily detect that yes, this was a watermark which is embedded into the image, even though it is invisible, but still in some cases in fragile watermarking, we are able to get it checked. Sensitivity, fragile is very highly sensitive, as I have explained earlier also, that even a slighted change in the image or even the slighted tampering to the image, the whole image will be destroyed and the receiver will never be able to retrieve that image. So purpose for the fragile is usually integration authentication, whereas purpose for the robust is copyright protection and ownership. So after analyzing to all these things, this paper has used fragile watermarking as a main motive for the paper was that the image or the sensitive information should never reach the intruders who are trying to attack the image. Now, this is what the framework that is proposed in the paper. So firstly, what has happened that there are two images, watermark image 1 and watermark image 2. These two images are those to whom we need to provide the protection. So what we will do, the fusion is performed on these two images. After the fusion is performed, we have received one image, that is a fused image. So what we will do for the fused image, the scrambling is performed. After scrambling, some kind of output we get. So this will go to one of the input of the zero watermarking. The second input to the zero watermarking coming from the cover image. This is basically my cover image in which I will hide the watermark image. And the watermark image in this case is just the fused image. So on the cover image, what I'm doing, I'm taking out the feature maps using ResNet 50. On those feature map, I'm using some kind of transformations, that is a DWT SVD. And from that, I have extracted the S matrix. Now, after performing DWT, I have taken low frequency images. After performing DWT, the image is divided into four major parts. That is low, high, low, and high frequencies based on the image. So from that, I have taken the low part. On that low frequency bands, SVD is performed. And when I perform SVD on those, I get three matrices, S, V, and W. Basically, from that, I have taken S matrix from that, which is describing the geometry of that. The rest of you, that is U and V matrices, they are more prone to the intensities and all those things. So after that, I have performed hashing on that and I have received one of the hashing string. Now here you can see that the matrix has been converted to the string part, and that after that scrambling has been performed on that string. Finally, this is the second input which is going to the zero watermarking, and finally the zero watermarking that has produced a key to me from where I can further in future extract the watermark from the cover image. The next, here I have used one of the fusion here. So what is the fusion algorithm used in the paper? The fusion algorithm used in the paper is basically based on PCNN networks and WEWSCML rules. So what is happening? This is my one of the image and this is my second image. On both the image, I am performing DTCWT. This is one of the transformations. So when I will pass this, so I will have two subbands, that is high pass subband and low pass subband. Here also, when I will perform this, I will converting the image into two subbands, in high pass subband and low pass subband. In both these subbands, what in this low pass subband here and here this low pass subband, I'll be performing NSST. So NSST, what does it do? It converting into the subsamplings, and when I will having this more subsamplings, I will again have this high pass subband and low pass subband. And further that, I'll be based on the rules of PCNN. What I will do, I will convert that again to low pass subband, and this is this. So after all these things, the inverse of both this will be applied on that, and after one inverse is given, I'll get the fused image from this. So this is how the fusion algorithm work in the paper. Further, the result for the fusion algorithm is this. We can see that here was the pair 1, and this is my image in the pair 1, this is my image 1, this is my image 2, and after the same algorithm is applied on these images, I get this one as my fused image. Similarly for the pair 2 also. This is a table which has been shown. I have such like 50 plus images. The pairing has been performed on 50 plus images, and after that the results have been analyzed on them. These are the results that I have received on the average of 50 pairs. So in this, what is happening, we can analyze from the results that the results are very much accurate on that purpose. So this is one of the best algorithm which can be used for the fusion. Further, for the zero watermarking, these are the standard images I have used as a cover image. These like the images like 1 to 12 which has been shown here, these are the standard images. 1 to 10 or 11, 1 to 11, these are the standard images which have been used as a cover image for zero watermarking. And further, the testing has also been done on the average of 250 plus MRI images. So these are the attacks which are performed on after the zero watermarking has been performed, so that we can check the fragile watermarking, that whether after performing this attack are we able to retrieve the image or not. So attacks are shown here. Here I have used the notations A1, A2, A3. Basically, their notations are given here in the table, and these are the images I1, I2, I3, whose notations are in the further results. So first of all, which deep learning technique one should use? So the test was performed on ResNet 50, ResNet 101, VGG 19, DN 121, MobileNet, and after performing the results on all, we have check that there should be a balance between the time complexity and the results, as we can't use a very high dense layer. Of course, that is going to perform a better result, but time complexity we also need to consider in that case. So after performing all those attacks and taking the average of all those attacks, it was analyzed at less than 50 is giving me the best results rather than all other things. So the results of ResNet 50 has been analyzed on different images with different attacks. So the results are shown here. As you can see that these are basically the NC values. NC values is like we are comparing the image which has been embedded, that is a watermark image, and the image that is extracted from that. So NC values there are very less, they are negative also. Negative means the dark has been converted to light and light has been converted to dark. Usually the NC remain higher than 0, but if it is negative, it directly symbolizes that only the dark has been converted to light and light has been converted to dark, because the value of image can't be negative. So here negative is that symbolizing. So the NC values are very less. They are 0 0.08, 0 0.07. They are very, very less than 1. That means directly after performing this attack, we are really unable to retrieve the image that was actual image. So this is fulfilling the main purpose of fragile watermarking. So finally, we can say that the proposed method in this manuscript is highly effective solution to this problem. This technique initially employ NSST DTCWT based multimodality image fusion method to generate the final watermark. And even by using the avalanche effect of the hashing algorithm SHA512, this method is highly fragile. So any slight change in the watermark image can completely destroy the confidential information stored as a watermark image, effectively preventing any unauthorized access. Further, the implementation of virtual embedding with zero watermarking instead of actual embedding significantly reduces attack surface, as it conceals the availability of the watermark image in the cover image. Here we can see in the proposed methodology, here there is a hash string hashing. The hashing method proposed in the paper is SHA512. Why we have used that? Because after performing the hashing, what it will do, it will produce a string of 512 bits. And this is the main step where the fragile watermarking come into the action. Because we have seen that even there is an avalanche effect of the hashing. That means even the 1% change in the input string, that will like completely change the output what I am receiving from that. So here there is a major part of fragile playing a role. So what do we mean by zero watermarking here? Also, zero watermarking means there is a virtual embedding. Actually, in reality form, there is no embedding being performed, but virtually it is performed. When I say virtually, it means that I can extract the image completely from the key only here. So virtually in the zero watermarking, usually there are a lot of methods, but the one of the basic method is using the XOR of the images. And after taking XOR, what we'll see the compare. What is the output I'm getting and what was the input. On the basis of that comparison, only the key is performed. And after that key and that compared output that we have received, basis on only those two things, will be able to regenerate the watermark image which was embedded in it. Embedded in the sense of virtual embedding. It is never actually get embedded into it. That is why there is one of the disadvantage of fragile watermarking, that the image is easily getting detectable. we'll be able to detect it whether there was embedding or not. That disadvantage have been overcome in this proposed framework by virtual embedding. That in actual form there was no any real embedding. If one of the attacker from outside is going to check that how the embedding was done in that, what is embedding was done, he or she will never be able to check that which was embedded things. That is why here the paper has proposed a zero watermarking, that is the virtual embedding which has been taken place. So this was all the results, which directly shows that the performed methodology give a very good results, that it can be implemented in real life as well. Thank you so much.